The last species of early Homo we are going to discuss are Homo ergaster and Homo erectus. These hominins had even bigger brains and more elaborate technology than the previous hominins. And we finally get out of Africa. Fossils are found in Africa, Europe, and Asia. We will start out with the African ones, called Homo ergaster. Then we will go over European finds, and then Asian ones. We'll look at the history of their discovery, their morphology, and their dates. We will finish by talking about the archaeological record and see what we can infer about behavior. Sometime around 1.9 million years ago, a new hominin appeared on the African scene. This is Homo ergaster, and he is found in various places around Africa, including South, East, and North Africa. Here's one of the better skulls found from Cubiphora. You can see the large brain, the big brow ridges, but a smaller face when we compare it to earlier hominins. Here's one of the skull fragments from South Africa. They're a bit scrappy, but it's still important to show the continental distribution of ergaster. This was a particularly amazing find. It was the skeleton of a young man from Lake Turkana. You can see how complete the skeleton was, and it has an associated skull and mandible. It's a boy who was probably around 11 years old when he died, and he was already 5 foot 6 inches tall. As an adult, he would have been over 6 feet tall. That's why he's called the strapping youth. This is the first ever complete female ergaster pelvis found. It's found from the Middle Awash area in Ethiopia. Why it's important is it can give us some insight into how big the babies were at birth because we have the size of the birth canal. Here are the important facts for ergaster. He was also one of the species found by the Leakeys. The geographic distribution is Africa and Eastern Europe, with important sites of Cubiphora, Swartkrans, and the site of Manisi in the country of Georgia. And he was around for approximately 1.9 million years ago to roughly 500,000 years ago. Overall, the appearance of ergaster is pretty different from the early Homo specimens. You notice here a cranial capacity of between 8 and 900 cc's. We have a prominent occipital torus, that's a little bulge in the back of the skull. The nasal aperture, the opening of the nasal area, projects forward. This means the nose would have projected outward and had openings downward, like in modern humans. Look at a smaller face and teeth, a still well-developed brow ridge, but thick cranial bones and a long, low skull. For the first time, the bones of the skeleton are more like modern humans than anything else. Though they're similar to modern humans, both the pelvis and the femora are very robust with pronounced muscle markings. This indicates a habitual biped in the same way as modern humans, but the increased robusticity suggests they were subject to some kind of extraordinary stress. Let's think about this increase in body size compared to early Homo. Remember, early Homo was tiny and had primitive body proportions. But soon after early Homo appears in the fossil record, we have Homo ergaster specimens showing up with much larger body size and modern bipedalism. There must have been a major change. Let's think about what selective pressures might have been operating at this time that this major transition was going on. This depicts the climate changes and habitat changes taking place in Africa during the time periods that we've been talking about. We see some important changes in the climate record and in the record of other fossil animals happening right around 2 million years ago. At this time, we start to see open savanna grassland animals dominating the fossil assemblages. The appearance of ergaster right after 2 million years ago fits in well with this evidence. If you are a hominin and you find yourself spending more time in the open savanna, it would be very advantageous for you to be larger in body size. You can fight off predators better. Also to be tall and thin, so you're less exposed to the sun. And obligate bipedalism means you can more easily travel among resources. Being long and linear seems to follow the latitudinal gradient seen in humans adapted to tropical climates. And it also suggests they were dissipating heat like we do. The idea here is that they may have been losing their body fur and developing sweat glands. So they're sweating as a way to dissipate heat. That would give them an advantage with hunting because the other animals have to stop and pant or they will overheat. We can continue to be active, especially during the day when other animals try to avoid the heat. Another thing that probably developed at the same time, given all of this skin we are now exposing to the sun, is the production of melanin. That will result in the origins of different skin tones. So the changes we see between early Homo, habilis and rudolfensis, and Homo ergaster are a response to the environmental changes that were taking place during this time. So that is the time frame and morphology for ergaster. Remember the African species from this time period. Now we come to the earliest hominins found outside of Africa. A discovery from Georgia shows how and when hominins began their dispersal. The site of Menisi is in Georgia between the Black Sea and the Caspian Sea. It's considered by many to be a European site, though it's pretty far east. Material is dated by potassium argon to about 1.8 million years ago. And over the last 20 years, fieldwork has turned up at least 4 skulls, 3 mandibles, and lots of postcrania and stone tools. Remember, the earliest ergaster in Africa is dated to 1.9 million years ago, so Menisi dates show an almost immediate dispersal from Africa by these hominins, and the placement of the site gives insight into the migration routes. These are 2 of the skulls found from Menisi. The one on the left is from a very old man. He only had 1 tooth left in his mandible, but clearly lived for a very long time after losing his teeth. This tells us that these hominins may have been taking care of their elderly. The second skull is from one of the smaller individuals with rather delicate brow ridges and a smaller cranial capacity, coming in around 600 cc's. The other skulls have larger brain sizes ranging from 650 to 780. They have typical ergaster traits like the long low skull and the supraorbital torus. They also have big canines, which is a relatively primitive trait. Some postcranial bones have just been found. They indicate a modern leg. We see a complete femur and tibia, but the arm bones look more primitive and suggest these guys might still have been doing a lot of climbing. So more primitive than the strapping youth, but actually older, 1.8 versus 1.6 million years ago. The body size estimates are around 5 feet and 100 pounds. The site also has lots of Oldowan tools, so it appears that hominins were able to migrate successfully out of Africa armed only with these simple tools. So once these hominins left Africa, it did not take them long to spread out to Asia. They doubtless spread into Europe as well, but we don't have much of a record for them there until a bit later in time. The Asian fossils are different enough from African fossils to warrant a different species name, Homo erectus. You can see from the red that we have fossils from India, China, and Java in Southeast Asia. The history of the discovery of this taxon started in the 1800s. Ernst Haeckel was a German biologist and a big fan of Darwinian ideas on evolution, but he disagreed on where to find the earliest members of the human lineage. Darwin had suggested Africa as a likely place, since that is where chimps and gorillas are found, and to him, we seem to be more closely related to the chimps and gorillas because we looked more like them. But Haeckel thought humans must have evolved from gibbons, since gibbons are the only apes that appear to walk bipedally when on the ground. And this is because the gibbons' arms are so long that in the rare times they're on the ground, they have to lift their arms up or they would drag. So Haeckel thought that fossils of early hominins would be found in Southeast Asia, where gibbons live today. He even came up with a name for this mythical ancestor long before anyone actually found any fossils. He called it Pithecanthropus, or ape man. Haeckel's teaching strongly influenced a young Dutchman by the name of Eugene de Moix, so much so that he joined the army so that he could travel to Southeast Asia in 1892 and look for fossils of this supposed Pithecanthropus. Dubois started excavating on the banks of the Solo River in Java. He found a skullcap and a femur near the village site called Trinnel. The skullcap was very primitive looking. It had very thick cranial bones and a large brow ridge and was smaller brain than modern humans. However, the femur looked just like modern humans. Dubois was so overjoyed that he announced that he had found Pithecanthropus and gave its species name Erectus, since the femur indicated erect posture. Since the announcement of Dubois' Java material, many more specimens similar to it have been found in other parts of Java and from China. By the 1950s, most felt that the Chinese and Javan material were similar enough to modern humans to belong in our genus of Homo, so all Asian material was put into Homo erectus. An important site for fossils of Homo erectus in Asia is that of Zhoukoudian Cave. It's the site of the so-called Peking Man, and it's produced a lot of material. It's a cave pretty close to Beijing. It was excavated in the 1920s after some Western scientists noticed some human-looking teeth for sale among fossils in a Chinese drugstore. They were originally mined for fossils called dragon bones, which were ground up and sold by druggists as aphrodisiacs, and eventually provided the largest known sample of Homo erectus fossils. Davidson Black, a doctor working in Beijing, worked at the site, and when a large human molar was found, he actually wore it in a vial around his neck. After Black died in 1933, Franz Weidenreich, a German anatomist, continued to work the site. Weidenreich eventually had a collection of hominin fossils of more than 40 individuals. Then World War II began, and the Japanese army occupied China. Weidenreich decided to leave the country and had detailed casts made of the Zhoukoudian material that he took with him to New York. He entrusted the original fossils to the U.S. Marines who were helping to evacuate the American embassy. With their Marine caretakers, the fossils were due to be shipped out on December 7, 1941. Perhaps you know your history, you know what happened on December 7, 1941, Pearl Harbor. The Marines were captured by the Japanese, the fossils disappeared, and they've never been seen since. So we have Weidenreich to thank for the casts and the detailed studies that were made and brought with them to New York. Here are our Erectus facts. The dates are a bit tricky because the deposits in Asia are difficult to date. There are poor excavating techniques, difficulties with biostratigraphy, and the lack of volcanic material. But you can see that the oldest specimens appear to be contemporaneous with the oldest ergaster in Africa, and not too long after the first members of the genus Homo arose in Africa overall. So this spread out across the world appears to have been accomplished in a very short amount of time. The brain size is bigger than ergaster. Most of the specimens have cranial capacities over 1,000 cc's. However, it is similar to ergaster in the low skull, the prominent brow ridges, the occipital torus, and the smaller teeth. What is different in the Asian material compared to the African is that the traits are emphasized. The supraorbital tori are thicker and more pronounced, and the occipital torus is more pronounced. Another difference from ergaster is that the skulls show a sagittal keel. It's not a crest really, but you see a depression along the side of the sagittal line, and it gives the skull a tent shape from the rear. And the cranial walls are even thicker than in ergaster. These skull caps show the keel, the brow ridges, and the long, low skulls of Erectus. So now we have covered the basic facts for these two taxa, ergaster and Erectus. And I've shown you that they are the first hominins to spread out of Africa. At this point in time, we see some major changes. We see an increase in body size and the appearance of obligate bipedalism, which means they are like modern humans. We also see an increase in brain size throughout the history of these two taxa, so there are definitely some major changes going on. We already talked about the climate changes happening at the time as important selective pressures for these changes in our evolution. But why is ergaster the first hominin to be found outside of Africa? Is it because of changes in their technology, in their anatomy, in their subsistence? There are certainly changes in their technology. The stone tools that we find associated with ergaster and Erectus in Africa and Europe are different from the Oldowan industry. We call the next tool industry the Acheulean, because the diagnostic tool was first found at a site called Saint Acheulean in France during the 19th century. The diagnostic tool within this industry is the hand axe, called the Acheulean hand axe. The Acheulean industry is much more sophisticated than the Oldowan. These hand axes in particular are a totally new kind of tool called a biface, in which the core is flaked on all sides with the edge along its entire circumference. The standardized form of the hand axe suggests that these hominins had a design in mind when they made each tool. In contrast, older one tools have haphazard appearances, and no two are exactly alike. Hand axes have very consistent proportions, and it shows that there was a template for this tool that was shared across a great time range and distance. There are many sites across Europe and Africa where hand axes are found in association with animal bones, though no hominin bones are found there. It tells us that this is a very successful toolkit and that meat eating became an important part of the diet of these hominins. The Acheulean industry appears in Africa about 1.5 million years ago and lasts worldwide to about 200,000 years ago. It also belongs to the lower Paleolithic time period. Other aspects of technology include controlling the use of fire. This was probably one of the most important advances ever in the history of hominins. It would allow them to move into colder climates and survive, to protect themselves from predators, and to process their food in a new way. Lightning strikes and the fires they caused were probably common enough that hominins were familiar with fire, but as far as we can tell from the fossil record, they only learned to control it sometimes after 1 million years ago. That is when we see definite hearth ash layers in caves, such as Zhoukoudian Cave. So these guys could walk long distances, could protect themselves better, and this probably led to an expansion of their home ranges. They weren't as limited in the size of the territory they could maintain. When we think about them spreading out across the world, it is probably best to think about it in terms of expanding their range, not just picking up and moving. As I said, meat eating clearly became an important part of the diet of these hominins, and that subsistence strategy allowed them to expand their territories, their ranges, which made it easier for them to spread out to other parts of the world. They weren't tied to specific habitats like chimp and gorillas who ate leaves and fruit. They could inhabit all kinds of areas with this kind of subsistence strategy because meat is found everywhere. And so that ends our discussion of early Homo with the two species Erectus and Ergaster. Just to summarize, again, we have many changes appearing with these two species. They are found out of Africa. They have modern limb proportions, so they would have looked like us. They have a nose that looks like us. They probably lost their body fur and developed sweat glands, which means skin tones were perhaps developing. They may have been our first hunters and have mastered the use of fire. Going into colder climates such as Asia also suggested that they probably, in addition to the fire, had figured out a way to keep themselves warm by clothing themselves, even though that does not survive the archaeological and fossil record. So that finishes up this module on early hominins and early human evolution. So do what you gotta do, and then up next we will be talking about the evolution of modern humans.